All right, now we have a very well-worded problem that I did not need to edit because it's so well-worded. I wonder what my creaking chair is going to sound like in the video. All right, so it says an airplane is flying parallel to the ground at a height of 4 miles. It is headed. Okay, there. Okay, now it's the problem is good even if it's poorly worded. What it's supposed to be is good. Okay, so here's the ground. Here is our plane. So okay, I'll try to draw it. So I know it's gonna have its wing out here, and then okay. All the lights, and then there's a cockpit. Okay. All right, so completely unnecessary drawing. And then here's our radio tower. Dink. Okay, so this is 4 miles. If the radio tower were actually this tall, that's almost 4 miles tall. That would be amazing. I'm a bad drawer. Okay, anyway, so its air distance to the base of the station is decreasing at 400 miles per hour. And that air distance is, if we just pretend the plane is a single point, the air distance, I'm afraid I'm going to miss here. That's not going to help me catch it. Let's see. The air distance is this connected dots there. So if I called this C, I could say C prime is equal to negative 400. I hope me turning the paper all like that doesn't cause motion sickness. All right. And then it says find the speed of the plane. Now the speed of the plane, this should have been better worded. It should have said something like find the land speed of the plane. Find the, which is, if we were kind of tracking it with a laser, like how fast would that laser along the ground be moving? When the air distance from the base is 10 miles. So this is a when C is 10. C is not always 10 because that's shrinking, but it's there. So now that we have the correct setup, this is pretty simple. We know that a squared plus b squared is equal to c squared, and so since c is changing this time, I can't say that, but let's call this, I like to call my vertical b, but you can call it whatever you want. All right, so a squared plus b squared equals c squared. Sorry, I had to pause the video for a second. So I personally prefer to make b my vertical side, and I'm recapping like you were experiencing the pause that I just experienced. I don't know a. Oh, right. B's not changing. That height is not changing. You can say b prime is equal to 0. So another way for us to handle this is at the very beginning, I can say a squared plus 4 squared is equal to c squared. Because even though a and c are changing, my distance here is changing and my air distance is changing. Since that is not changing, that's always 4, I can say it's that. Or just, a squared plus 16 is equal to c squared. So this helps us when we take the derivative in a second. And it's, if I want to find out what a is, I probably am going to need to, because I know the derivative is going to be 2a prime plus, oh, this one's nice, 0 is equal to 2c, c prime. And if I'm trying to solve for, what am I even trying to solve for? The speed of the plane. Oh, right, the land speed of the plane. So I want to know what a prime is when c is 10. So since I'm going to want a prime, which that's not there, so we need to divide both sides by 2a. And get a is equal to c prime over a. Well, I'll have to find out what a is. So let's see. At this moment, that we care about, c, is 10. So a squared plus 16 is equal to 10 squared, which is 100. And 100 minus 16 is 84. So a squared is equal to 84. So a is equal to the square root of 84. And then bop it in and we're done. A prime is equal to 10 times negative 400 over the square root of 84. And we'll get, again, I don't really care at this point because we've solved it. This is a formality. A prime is equal to negative 436.435 miles per hour. Okay. All right, now I need to make sure that I actually answered this question because my uh-oh detector went off in my head and I was like, wait, a negative number, that means that side is shrinking. What's the question ask? The question says find the speed. Speed's always positive, so I need to say a prime is equal to 436.435 miles per hour. Minor, but that little dash makes a difference between correct and not correct. All right, on to also 8, or 8a. I could have just called it example not numbered, right? Since it goes 8, 9, 10, whatever. Okay. A person, 5 feet tall, walks at a rate of 4 feet per second away from a light that is 20 feet off the ground. So allegedly, this light is floating 20 feet off the ground. Now, I think it's attached to a light pole, but and that person is 5 feet tall, and they walk at a rate, here's their head, okay, at a 4 feet per second away from a light that is 20 feet off the ground. Okay, so when he is 12 feet from the base of the light, so this is a when 12. I don't know what I want to call this yet. Maybe I'll call this little a. When little a is equal to 12. At what rate is the length of his shadow changing? So if we think about this, the light's casting light and boom, goes right through his face. Whoa, and now there's a shadow back here, right? Okay, so this is his shadow. And we want to know what rate is the length of his shadow changing. I actually don't want to do part A first. I'm going to do part B first. Part B is more conducive to handling first. Okay, so I'm going to call this big A. Part B wants to know what is A prime when A is equal to 12. Because this is the very tip of the shadow. And so there's some really weird stuff happening. He's moving farther away here. And that means that the shadow is changing as well. And it's not necessarily that he's just moving along and the shadow stays where it is. The shadow's getting longer and longer and longer. If you ever watched yourself as you've moved toward or away from a light, you notice that. The closer he gets to the light, the more the shadow is going to be like right underneath him. And the farther away he gets, the more elongated it is. So, oh yeah, he's 5 feet tall. So 20 and 5, they never change. And you might notice that we have similar triangles. And this is what's going to help us so much in this problem. So we want to know that right there. And we do know that from little triangle to big triangle goes from 5 to 20. So we could say little to big, 5 to 20. But now we run into a little bit of an issue because I don't even have a name for this little side right here. So maybe I'll just call that B for the little little side. I'm not going to call it shadow because my 5s and s's look too similar. But we do know, let's set up a little if we know the length of the little is b, what's the length of the long? It's b plus 12. I have to go do my job now. More on this later.